Unit 5, Section 14.3 Worked Examples. A car manufacturer has 149 cars of a new model to be apportioned to 4 dealerships. The manufacturer decides to apportion the cars based on the number of cars each dealership sold in the previous year. The number of cars sold by each dealership is shown below. Use the table to answer parts A through C. Determine the standard divisor. To determine the standard divisor, we use this formula. Standard divisor equals the total population divided by the number of items to be allocated. The population here is the total of the sales, which is 13,410, and there are 149 cars to be allocated. So we're going to divide 13,410 by 149. And our standard divisor is 90. Determine each dealership's standard quota. To determine the standard quota, we take the sales for each dealership and divide by the standard divisor. So for dealership A, we're going to take 4710 and divide by 90. And we get 52.33. Generally, the answers will be expressed to 2 decimal places. So I got 52.33. And if I do the same process for the other dealerships, and I've written down the division that you're going to be doing right here, and I'm going to go ahead and put the numbers in. This is 4209. And dealership 3 is 31.22. And dealership D is 23.36. Now determine the apportionment using Hamilton's method. So what we do in Hamilton's method is we round down and we check the total. So for dealership A, we would round down to 52. For dealership B, we would round down to 42. Dealership 3 round down to 31, and dealership D round down to 23, and total those. And I see my total is 148, and I actually have 149 cars to allocate. So the extra car is going to be allocated to the dealership whose decimal was the largest. And if we look across here, we see that dealership D has the largest decimal, 0.36. And that's larger than any other of the decimals on dealerships A, B, or C, so that's going to get the additional car. So here's the final allocation, 52, 42, 31, 24, and when I add those up, I get 149. The next problem is going to use Jefferson's method. A small county with a population of 8,000 consists of 4 states, A, B, C, and D. There are 160 seats in the legislature that need to be apportioned among the 4 states. The population of each state is shown below. Determine each state's modified quota by using the divisor 49,400. So again, for each of the states, you're going to take the population and divide by that modified divisor that was given to you, 49,400. And when I go ahead and do that in my calculator for the first state, I get 38.62. For the second state, I get 59.11. For the third state, I get 18.26. And for the fourth state, I get 45. .95. All right, now, we're not done yet because for Jefferson's method, if you remember, Jefferson says round down to the nearest integer such that the total of those integers is the exact number of items to be apportioned. A little bit different than the Hamilton method. So if I look here, I've moved over those numbers here, and we're going to go ahead and we're going to round down. So we're going to have 38, 59, 18, and 45. And when I add those together, I do get 160. So the modified divisor that I selected in this case was actually the correct one to use. And the allocations do total up to the 160, which was the number of seats to be allocated. The next problem uses Adams' method. And in this case, we're going to round up after we divide by the modified divisor. And we have a small country with a population of 7.5 million, consists of 4 states, A, B, C, and D. There are 150 seats in the legislature that need to be apportioned among the 4 states. The population of each state is shown in the table, and we're going to use a divisor of 50,700. So if I take each state's population and divide by the 50,700, in the first case, I'm going to get 24.54, 24.54. And the second state, I get 53.87. And the third state, I get 17.38. And for the fourth state, I get 52.15. And then on the next page, I've brought those numbers over. And remember, in this case, we're going to round up. So for state A, we're going to go up to 25. For state B, we're going to round up to 54. For state C, 18. And for state D, 53. And when I add those up, I get the 150, which is the actual number of items we had to be allocated, the number of seats. And so that's how we did the allocation using Adams' method. The last method that we studied is the Webster method. And in the Webster method, after dividing by the modified divisor, we are going to round to the nearest integer. So we have a small country with a population of 5.6 million in 4 states, A, B, C, and D. There are 140 seats in the legislature that need to be apportioned among the 4 states. The population of each state is shown in the table. Determine each state's apportionment using Webster's method. Now they're suggesting here to start with the standard divisor, which is always a good place to start because sometimes the standard divisor will actually get you where you want to be. So the standard divisor in this case is going to be the 5.6 million divided by the 140 seats to be allocated, and that gives us 40,000. And then what I did for each of the states was take, for instance, in the first case, let me pull the calculator up and show you. In the first case, I took the 1,232,000 and I divided by that standard divisor of 40,000 and I got 30.8. And I did the same thing for the remaining 3 states. And then now we round to the nearest integer. So for state A, it's 31. For state B, we go down to 68. For state C, we go to 21. And for state D, we round up to 20. And in this case, actually, the allocations work out perfectly, so we don't have to go and adjust that divisor.